Assalamu alaikum, dear students. In this lecture we try to solve the numerical problem from the Marion's books, and I have selected the typical problems in which I expect that you will feel difficulty. So let's solve question 3. This question says, if a projectile is fired from the origin of the coordinate system with initial velocities and at an angle alpha with the horizontal, then calculate the time required for the projectile to cross a line passing through origin and making an angle beta which is less than alpha with the horizontal. So first we observe that we have projected a projectile with velocity v, which is making an angle alpha with x-axis. Oh no, this projectile cut this line, this straight line, which is making angle beta with horizontal axis at 2 points. The first is at its origin and the second is at more than, I think it is beyond the highest point. So it's cut at 2 points. We have to find the time required for the projectile to cross the this line between 2 points. So this we have to find the time from point origin to point P. So let's first we will write the equation of motion. The equation of motion is F is equal to ma. In this we resolve this force into two components. The first will be x component, as there is no force along x-axis. So we will write mx double dot is equal to 0, and along y-axis there is gravitational force and it opposes the motion, so my double dot is equal to minus mg. Now our task is to solve this equation for displacement and to their time. So first equation will give us the acceleration, its velocity along x-axis, vx will be equal to v naught cos of alpha, and the second equation will be gives velocity along y-axis, v naught sin alpha minus gt. If we further write this x dot as in term of dx over dt and integrating these equations, this will yield x of t is equal to v naught of t cos of alpha, and after integrating this equation using initial conditions y of t, this will yield us displacement along y-axis, y of t is equal to y v naught t sin alpha minus 1 over t gt square. So we have so far obtained the equation of motion along x and y-axis. So let it, for example, consider it takes time t naught to reach the point P. We are actually finding the time from the starting point to the point P. So let it takes time t from the origin to P. So what will, again let's come back, L cos beta, let it takes. So if its length is, its length of a inclination is L, let's go back, and if I erase this, then I will be able to draw lines on this diagram. The length of this incline is L, so we resolve this into two components. The first will be, one will be L sin beta in perpendicular direction and the other will be L cos beta which is in horizontal direction. So L cos beta is equal to horizontal component and L sin beta is vertical component. Equating the two components, L cos beta will be equal to horizontal components of displacement and L sin beta will be equal to vertical component of displacement. So the vertical component of displacement we already find out, this will be equal to L cos beta and the L sin beta, and the horizontal component is x of t. So this will, we will equate this to L cos beta. L cos beta is equal to v naught t cos of alpha, which is horizontal component. L sin beta which is the horizontal component of inclinations, we will equate this to y of t. So then what we will do, we will solve these equations to eliminate t. Let's we discuss it. Eliminating L between these equations. If we eliminate this L between these equations, this will give us gt naught over 2 t naught minus 2 v naught sin alpha over g plus 2 v naught cos alpha tan beta over g. So this equation will hold good if we equate these two quantities separately equal to 0. gt naught over 2 is equal to 0 either, or this bracket term is 0. So if we put this bracket term is equal to 0, this will give us t naught is equal to v naught over g sin alpha minus cos alpha tan beta. This is if t1, and the second time is t naught is equal to 0. It means that our projectile cut this line, this inclination for 2 times. First is at t is equal to 0. Okay, here it cuts this, our projectile v naught vector cut this line at first origin, and the second time it's at point P. So we have actually got 2 points. The first is t is equal to 0, and the second is this time. If we equate separately, put these equation, first term and the second term, one will give t naught is equal to 0, and the second will give t naught is equal to 2 v naught over g sin alpha minus cos alpha tan beta. So we have this required answer. Now let's go for another question. This question says, if a jet fighter now he is able to withstand an acceleration of 9g before blacking out. The pilot points his plane vertically down while traveling at Mach 3 speed and intend to pull up in circular maneuver before crashing into the ground. Here he used 2 terms, blacking out. In blacking out, we say that when a person or anybody feels a very greater acceleration than g, then all his blood of body move toward his mind. It means he feels some like of blacking out, means he has senseless. And the Mach 3 speed, this is Mach is ratio of velocity of object to velocity of sound. It is ratio of velocity of object to the velocity of sound. So what we have to find, we have to where does the maximum acceleration occur in the maneuvers, and the second is what is the minimum radius pilot can take. So let's solve this equation. This is a path that jet adopt when he will move on this circular path. So first thing is where its force will be minimum and where its force will be maximum. A jet fighter now he is able to withstand an acceleration of 9g before blacking out. The pilot point his plane vertically downward while traveling at this speed and intend to pull. Where does the maximum acceleration occur? So we will find that where its acceleration is going to be maximum. So generally we can write the expression for tension, n minus mg cos theta is equal to mv square over r, where theta is the angle between its vertically downward force and acceleration, which is always directed toward the center. If we find this normal force or tension here, so it will be like this and the weight is downward. So here angle will be 90 and here angle will be some like 0, and for this point if this follow a path of circle, so here this angle weight will be downward and its normal force will be upward. So angle between these two will be 180, but in this case angle will be 0. So n minus mg is equal to mv square over r. If we put these terms to the right side, then this will give us n is equal to mg plus mv square over r. This is because of this summation. This is the point where our normal force will be maximum. This is the maximum force which act at the bottom point. So where does the minimum force act? The minimum force will be act at point highest if we consider the ideas of a motion in a vertical circle and a horizontal circle. And the second question is, what is the minimum radius that pilot can takes? So if we recall the equation that mv square over r is equal to mg, we will balance these two equations because there are two forces acting on this while he is negotiating the circular path. The first is centripetal force which is acting, and the second is its weight. So if we read again the condition, he is able to withstand an acceleration of 9g before blacking out. So if he is at 9g he become blacks out, so before 9g its acceleration will be at 8g. So if we simplify this equation, m will cancel with m, and we will left with r, v and g. So we will put g is equal to 8g because at a is equal to 9g he becomes blackout. So we have to consider this condition before 9g. So this will give us a radius which is equal to v square over 8g. If we put v is equal to velocity of object to the velocity of sound. So velocity of sound is 300 and velocity of object is 3. So 3 multiplied by 300, this will be here speed, and 8 and g is the gravitational acceleration which he feels. So this will give us a radius in which pilots can negotiate the curve. Now let's move to the another questions. Question number 8. This is question number 8 from your own books, and this question says a projectile is fired with velocity v naught such that it passes through 2 points both a distance h above the horizontal. Show that if the gun is adjusted for the maximum range, the separation of that point is this. So let's consider a particle which is fired at velocity v naught, and this is fired with velocity v naught such that it passes through 2 points both a distance h. So let's consider these 2 points. The first is denoted by point P and the second is point Q, and both points are at distance h height. So we have to find the distance between these 2 points if the projectile is adjusted so that for a maximum range. So first we have to write the equation of motion for projectile. The x equation is x is equal to v naught t cos of alpha, and the second is y components, y is equal to v naught t sin alpha minus 1 by 2 gt square. So if we want to solve this equation for the time, then this will give us time for projectile, which we already know. We don't need to calculate it again. So we put this equation equal to 0. This will give us the time for the projectile, because if we put y is equal to 0, then this will give us the time of projectile, and then this time of projectile is 2 v naught sin alpha over g, and the range of projectile will be equal to, if we put this time into this expression, this will give us the range of the projectile, which is equal to v naught square sin 2 alpha over g. So as we are seeking for maximum range, here he is talking about, then we have to set our projectile for maximum range. So the maximum range occur for angle pi over 4. If we put these equation pi over 4 in both of the equation, an equation for x and an equation for y, this will give us x is equal to v naught t over under root 2, and similarly for the y component, this will give us x is equal to v naught over under 2 minus 1 by 2 g t square. Now if we solve these two equations, this equations and another equation which we had previously seen, this equation. So if we solve these two equations and eliminating t between these two equations give us this. If we find t from the first equation and put in this equation, this will give us in the second order quadratic equation. Now this equation, the x coordinate of the projectile and the y is equal to its height. So put y is equal to h, because we are actually finding the distance between 2 points, the horizontal distance between 2 points which is at height h. So we will put y is equal to h and x coordinate of the particle. This equation will give us the two roots, x1 and x2. So the first root will be represented by x1 and the second root will be represented by x2. So if we take the difference between these two roots, this will be x2 minus x1, and this is our required expression. If we take the difference of these two equations, so it will give us the required answer. Let's again another question number 9 of the books. Consider a projectile far vertically in a constant gravitational field. For the same initial velocity, compare the time required for the projectile to reach its maximum height. The first case is for zero resistant force and the second is for a resistant proportional to the instantaneous velocity of the power. So we have to find the ratio of their time when there is zero resistance and when there is a resistance which is proportional to the single power of the velocity. So again we will solve the equation of motion for the two, and we have already, the first case is when there is no frictional forces. So we can simply solve this equation, m delta v over delta t is equal to minus mg over only gravitational force is acting at this in this case. So we will integrate this equation and this will yield us to v is equal to minus gt plus v naught at maximum height, because we have to find the time for the maximum height. If we go back to questions, compare the time required for the projectile to reach its maximum height. Its maximum height velocity of the projectile is at 0. So this we will put here the velocity equal to 0 for maximum height. So this will give us the case number 1. T naught is equal to v naught over g. When we consider the frictional force, the equation of motion will be modified like this: minus k mv minus mg is equal to this. So if we solve this equation, again this will give us v of t minus g over k plus this whole expression. Again we are seeking for maximum height, so at maximum height velocity will become 0. So we will put the velocity expression equal to 0, and this will give us v naught is equal to g of k exponential k over kt minus 1. If we again manipulate this equation further for t, so taking anti-log from both sides and solving this equation, then kt will become log of 1 plus kv naught over g. Now we can expand this logarithmic series using the idea this idea of this series. Log of 1 plus z is equal to z minus z square over 2 plus z cube over 3. If we put these equation in this form, so this will modify like this: t is equal to v naught over g 1 minus kv naught over 2g plus 1 over 3 kv naught over 2g whole square. So we have to compare them with the when there is no fraction. If we put k is equal to 0, it means we have no fractions. If we put k is equal to 0, it means our this equation and this equation become equal. So our time should then become equal to 0. Time for the case when there is no fraction, this is equal to v naught over g. And again if we put k is equal to 0, in this case this expression will go to 0 and this expression will go to 0, and we have got T is equal to V naught over G, which is the case when there is a no frictions. It means we have solved our question for the resistance case correctly. So if we solve another question, this question says that consider a particle of mass m which is moving and starts its motion from rest in constant gravitational field, and the condition is if the resisting force in this case is proportional to kmv square, no resistant force is proportional to the second power of the velocity encountered. Show that the distance s the particle fall in accelerating from v naught to v1 is given by this expression. If the body takes its motion from rest, it means how much distance it will cover when its velocity change from v naught to v1. So we have to show this when its velocity reach from point from v naught to v1, so its distance will cover like this, so it have to cover this distance. The equation of motion is md square ma will be equal to frictional force and gravitational force. So we will solve this equation. We can write d square x over dt square is equal to dv over dt, because we can write acceleration double derivative of displacement or single derivative of velocity. So if we use chain rule, then dv over dx and dx over dt is equal to velocity, and dv over dx is another term which we learn. If we put this expression, this d square x over dt square in the form of v delta v over delta x, so our equation will modify like this, and separating the two terms of the velocities and displacement. If we separate the term, then v delta v minus kv square plus g into delta x. If we integrate on both sides, this will yield to minus 1 over 2 k log of minus kv square plus g, which will be equal to x plus c. And this constant can be find out when v is equal to v naught when x is equal to 0. So this constant will come out to be minus 1 over 2 k log of kv naught square plus g. So if we put this constant back to our original equations, then this will give us x is equal to 1 over 2 k log of minus kv naught square plus g and minus kv square plus g. Actually, if at origin velocity is v naught and the velocity at later point is v1, then s is actually this distance, because we are seeking the ratio of the velocities. So velocity at origin is v naught and velocity at later point is v. So this is the our required distance. So let's stop here, and we will discuss in next session for further.